Hello, my pre-calculus kids. Today we are going to start the last section in this unit, section 9.3, that is talking about evaluating trig functions. So it kind of is a continuation of what we did in section 9.2, and that's what these beginning questions are going to be like. So they want you to find the exact value of these trig functions, and they tell you the cosecant of pi over 3. So for the first ones, all you need to do is go to your handy-dandy chart that we used in the last section. They want the cosecant of pi over 3. So it's a positive pi over 3. You go to your pi over 3 column and go across to cosecant. Here it is. And your answer is 2 square roots of 3 over 3. And so that's your first one here, 2 square roots of 3 over 3. The second one, 510, if you look at your chart only goes up to 360 degrees. So 510 is not even on your chart. And you're like, what the heck are they talking about? I can't use the chart for that, but really you can, because if I were to graph a 510 degree angle, I would be going around 360, but then the question is how much more would I have to go beyond that to get to 510? So if I take 510 and I subtract away 360, the full circle I just made, that leaves me 150 left. So that means I need to go 150 more. That's 90, and I'm not quite getting to 180. So this is where it would land. So the secant of 510 degrees is the same exact place I'd go if I were the secant of 150 degrees. And guess what? 150 degrees is on your chart. So if you go to 150 degrees, that's here. You want the secant, go to secant, that's here. And that would be negative 2 square roots of 3 over 3. So negative 2 square roots of 3 over 3. If they ask you for the cosine of a negative 135, again back to the chart, negative 135 is here, and I want the cosine of that, so I'm going to go over to cosine. Cosine is here. That means it's the negative square root of 2 over 2. Let's try a few more of those. The secant of 4 pi over 3, well 4 pi over 3 is on your chart again. Find 4 pi over 3. You are looking for the secant, so go over to secant, you get negative 2. So this one will be negative 2. Here's another one that is of those roundy round whirly guys, 945 degrees. Well, think about that guy if I graphed him. Here's 360, one full circle. If I go around again, now I'm at 720, another full circle. So if I go, I want to know what this is, 945 minus 2 full circles, 720. Gives me 225. So this would be equivalent to, if I kept going, over here I'd land in the third quadrant. This would be the same thing as the cotangent of 225. And that guy is on my chart, so I find my chart. Cotangent of 225. 225 is here. Go over to cotangent, that's at the very end, and I get a value that is 1. And so that's my answer for this guy. Last one like this with the chart. If I take the cosine of negative 210, you find negative 210, and I want to know what the cosine is, so go over to cosine. Cosine is going to be a negative square root of 3 over 2, and that's your answer. So these first ones, negative square root of 3 over 2, these first ones are just using your chart. Some of them you have to watch because they whirl around and you got to figure out what they're equivalent to, but what they're equivalent to will be something that's on that chart. So they're the first kind, find the exact values. Then they want you to figure out the angles. Same idea, and we did these in section 9.2 as well. So these are not such a big deal. Again, it's a review. So I want the sine where the sine is negative square root of 2 over 2. Go to the sine column. Take all the places where you get a negative square root of 2 over 2. That would be 225 degrees. And if I keep going, 315 degrees. So those are my two answers for this one. 225 and 315 degrees. Next one they want to know, and I know I'm putting it in degrees because of the directions. If they had put this in pi language, then I'd give answers in terms of pi, but these are for degrees. Secant is 2. Go to the secant column. Here's the secant column. Where is it 2? At 60 degrees and at 300 degrees. Here's your answer for this guy. 60 degrees and 300 degrees. Couple more like this. Sine is the negative square root of 3 over 2. Go to your sine column. Where is it negative square root of 3 over 2? 240 and 300. Your two answers for this are 240 and 300. And then the last one where the secant is undefined. Again on your chart, find the secant column. Undefined at 90. undefined at 270. There's your two answers. So again, it's really easy when you have that chart handy for you to just read where that happens. So here's what this section really gets into. What happens when it's not on the chart, right? What do you do? So here's some that won't be on your chart. You got the cosecant of 70 degrees. That's not one of your values from the chart, so you can't use that. So what you need to do is actually use the calculator. If you are able to use Desmos, you can do that. If you want to use Google Calculator, you can do that as well. Sometimes you have to make sure that you're in the right mode, whatever calculator you have. So I'm going to do it on our normal calculators, our graphing calculators. And what I want to know is figure out what the value is for these things. The problem is, if it's sine, cosine, or tangent, you have sine, cosine, and tangent buttons, right, on your calculator, sine, cosine, tangent. Problem comes when you don't have, they use secant, cosecant, or cotangent because you don't have those buttons. So what do you do? And that's what I wrote out for you here. First of all, you got to watch your calculator mode. Make sure it's in degrees for the ones that are degrees and radians for the ones that have pies. If they tell you that you want to find cosecant, cosecant, we've seen this before, is reciprocal with sine. So all I'm going to do is take 1 divided by the sine of that same angle. So if I apply that rule to this first problem, cosecant of 70, cosecant, you don't have a cosecant button, so you're going to turn it into 1 divided by the sine of 70 degrees. And really that's all you need to put into the calculator. So let me show you how it works. So in my calculator, first of all, I've got to check my mode. And degrees is highlighted, so I'm good. I can keep going. And I'm taking 1 divided by the sine of 70. So put it in just like that, 1 divided by the sine of 70, and it gives me my answer, 1.06. So my answer for this first one is 1.06. You can round it to 2 or 3 decimal places, whatever works for you. Let's keep going with the ones that are in degrees, so I don't have to change my mode. This one would be a radians because it's in pi. We'll come back and do that in a minute. This one's the cosine of negative 47. Well, you have a cosine button, so you don't have to do any conversions on this. Just hit cosine, and then you're putting in negative 47. And it tells you you've got 0.682. That's your answer for this guy, 0.682. Cotangent of 140, well, there's another degree one. We're doing all the degree ones first. Cotangent, I don't have a cotangent button, but I use my reciprocal rules, and so I'm going to do 1 divided by the tangent. So 1 divided by the tangent of that same angle, 140. So again, I go to my calculator and I say, all right, what is 1 divided by the tangent of 140? And out pops negative 1.19. Negative 1.19. Cosine of 3 pi over 5, we'll come back to that because that is a radian. And then I've got the last one is the cosecant of a negative 247. Cosecant, I don't have a cosecant button. So I'm going to use my reciprocal rules, just like the first example we did. This one's going to be 1 divided by the sine of negative 247. And so that's what I'm putting in my calculator. 1 divided by the sine of negative 247. I get positive 1.09. All right, let's change the mode and do the last couple. So if I take my mode, I go down, change it to radians. All right, now I'm going to try the last two. First one is a tangent. I have a tangent button, so I don't have to do any special conversions. All I do is put in tangent. And then pi is over here, second, and then the up arrow. Pi divided by 5. Just like it looks. Gives me an answer of 0.73. This one's 0.73. And then the last one is the cosine of 3 pi over 5. And again, I have a cosine button, so I can just cosine. Put in 3 pi divided by 5. And that gives me an answer of negative 0.31. All right, so there's our first page of examples, how you find them when they are not on your chart. The second part of the lesson gets into this, finding the angles when they're not on the chart. Remember these that we just did, where we had all these values, we could figure out exactly what angles had that particular sine value? What happens if it's not something on your chart and you want to know what the angle is? It's a little bit more work. And so it comes back to, remember these things that we did in the last section. What quadrants are these positive? What quadrants are these negative? And actually it might have been in section 9.1 that we did this kind of thing. So again, I drew up the chart for you, the same chart that we did back in 9.1. And what we need to do is what's called finding the reference angle. That's something that we did in this last section in 9.2. And so everybody's positive in the first, sine and cosecant are positive in the second, other guys are negative. Third has tangent and cotangent positive, everybody else is negative. Fourth has cosine and secant positive, and everybody else is negative. And so what we're going to do is we're going to figure out problems that look like these at the bottom here. The cosine of theta is a negative 0.5299. And what I need to do is figure out what the reference angle is. And so if I figure out the reference angle, here's how you do it. It's this thing that I bulleted over here. You take whatever the trig function is, in this case cosine, to the -1. You're going to do a second cosine in your calculator, and you're going to input a positive decimal value for this. We'll talk about the negative part of that in just a minute, but what I want to do is figure out what the reference angle is. So if I take this particular problem, I'm going to my calculator, and I want second cosine. I want the cosine to the -1. And then I am putting in a positive 0.5299. All right, here it goes. Oh, I'm in radians. That's not a good thing. I want to be in degrees. Let me go back and change me. Because the reason I want to have it in degrees is because, see my directions? My directions say your answer needs to be degrees. So let me try that one more time. Cosine to the -1, second cosine of 0.5299. And again, I'm putting in a positive 0.5299, not the negative that's on my paper. It gives me a value that's 58.001, yada yada. Really close to 58. You can round that. It's close enough where you can round that one to 58 degrees. So what I did was I put in my calculator, I put cosine to the -1 of 0.5299, and out popped the lovely angle of 58 degrees. All right, so that's part one, find the angle. Part two is go back and look at this value. Is it positive or is it negative? And we can see that it's asking me about where the cosine is negative because it's a negative 0.5299. So I've got to go up to my values up here, and I want to know which quadrants has a cosine that's negative. Not here, he's positive. But in the second quadrant, he is negative. So one of the places that I'm going to put for this is cosine is negative in the second quadrant. And there should be a second place where that happens. If I keep looking at my quadrants, here's another place where it's negative. I've got a cosine is negative in the third quadrant. And so what you're going to do is you're going to take your 58-degree angle and see these little things I wrote off to the side? These guys here? You're going to take your number, your 58 degrees in this case, and you're going to put it into these two quadrants doing that rule. So this is 180 minus 58 degrees. This one's going to be 180 plus 58 degrees. Okay. If I were to do that and actually do the math out for that, that gives me 122 degrees for this guy, and it gives me 238 degrees for this guy when I subtract 58, when I add 58. Oh, you can't see me. Now you can see me. Those are the two places where this cosine would equal a negative 0.5299. Let's check it out and see. If I take the cosine of 122 degrees, look at that, negative point. Oh, you can't see me. No, now you can. How about was my other one 238? Let's see, cosine of 238. 238. There it is. You can double check yourself that those are really the values for those angles that give you that particular decimal. All right, let's take a look at, let's go over here to this one that's sine before we go on to the cosecant ones that we don't have on the calculator, because we've got to play with them a little bit. So another one kind of like this one. Sine of theta is 0.788. I want to figure out the reference angle, so I'm taking sine to the -1 of a positive 0.788. That's step one. Sine to the -1 of 0.788. And I'm going to go to my calculator and I'm going to ask what that might be. So I want second sine. I want 0.788. Gives me 51.99899. So I'm going to round that again to 52 degrees. By the way, if you're using Google Calculator, you need to put in, you would put in this, it's kind of weird, put in ARC sine, and then put in 0.788, and it'll give you the 52 degrees. Arc sine is the same thing as sine to the -1. So in the language of that Google calculator, I know that it does it with this arc in front of it. All right, so 52 degrees is my angle. Now I have sine is a positive 0.788. So sine is positive. I want to know where that happens. What quadrants has a sign that's positive? So I go back to the top of my page. Everybody's positive in the first, and sine is also positive in the second, not in the third or fourth. So my answer for this is the first quadrant and the second quadrant. So I'm looking at these things off to the side. In the first quadrant, it's kind of fun. It's exactly what the angle is. So in my first quadrant here, it's going to be 52 degrees. I don't have to do any math to that at all. But when I go to the second quadrant, well, the second quadrant, the rule is take 180 degrees and subtract my angle from it. So this one's going to be 180 minus 52. And so if I take 180 and I subtract away 52, I'm at 128 degrees. And they're my two answers for that one. All right, so then what happens, though, if I get one of these crazy cosecant, secants, or cotangents that are not on my calculator? I can't just do a second tangent of those things. So what I need to do is use the reciprocal rules again, but a little differently than you did in those last problems. The sine of my angle is going to equal 1 over 1.14. I use the reciprocal rule, but I reciprocal that decimal value, the 1.14. So then I go to the calculator and I say, what is, you need to be able to see what I'm typing here, what is 1 divided by 1.14? You're not doing any trig, just figuring out the fraction. And it gives you 0.877, we'll round that to. So this equals, so really what I want to know is what's the sine of 0.877. And you see how now this is just like these other problems where it's just like this guy was. So you've changed it into something that is actually on your calculator. So now I'm going to take sine to the -1 of 0.877. So again, I go to my calculator, sine to the -1, second sine of 0.877. And now this one gives me 61.28. This one I can't just round it to 61 because I've got some decimals to it. So this one, because it's not a 0.999 or not a 0.001 like the last couple we saw, we've got to actually take a decimal. So let's take it to 61.3. So my angle is 61.3 degrees. Go back to the original thing. You want to know where cosecant is positive. So go to your top. Cosecant is positive in the first, and cosecant is positive in the second. So I'm going to put my 61.3 degree angle in the first quadrant and in the second quadrant. In the first quadrant, the rule is take it and keep it exactly what it is, 61.3 degrees. In the second quadrant, you take 180 and subtract 61.3 degrees. And if you were to do that, you get 118.7 degrees. So there's your two answers. All right, last one, secant. We don't have a secant button. So now I've got to do the reciprocal rules with this. So I'm going to take reciprocal with secant is cosine. Cosine is 1 over -1.36. So I figure out the decimal. Again, I'm not worried about the trig part of it yet. I take 1 divided by -1.36. It gives me a decimal, which is the cosine is -0.735. Now I'm going to use my rule that says I need to figure out what the trig function to the -1 is. So this is going to be cosine to the -1 of the negative I don't put in. Remember from the bubble that we did up here, you're only putting in the positive decimal point of what that is. So positive 0.735. So on my calculator, that's what I'm going to type in. I want second cosine of 0.735, not the negative. This one gives me 42.69. I'm going to go for 42.7. So my angle is 42.7 degrees. All right, now I'm ready to put it in the quadrants. This one is where the cosine is negative. right? Or secant, either one. They've got the same sine values. So if I go back to my top of my page, I want to know where is the cosine or secant negative. So, not here, but it is in the second, and it is in the third, and not in the fourth. And so you're going to take this thing and put it in the second and third quadrants. Second quadrant, third quadrant. Second quadrant is 180 minus 42.7. Third quadrant is 180 plus 42.7. And so then you just do out your math for those little guys, and you get 137.3 for this guy. And for the last one, you get 222.7 degrees. So you're still going to get two answers for these. It's just a matter of which quadrants they're going to fall into. All right, that's my intro for you. And next you'll watch the flip math video, and then I'll give you some extra practice problems that I'll do with you on another video. So good luck, happy Easter, and I'll talk to you soon. Bye.